Assalamualaikum and good day everyone. My name is Nurliyana and I'm pleased to present to you today on the topic of comparative analysis of imputation methods for missing environmental data, a case study on ozone concentration. This research is a collaboration between the University Malaysia Sabah, University of Malaya and University Science Islam Malaysia. First, let's discuss what is missing value or missing data and why it needs to be addressed. Missing value or missing data is the data set comprises either empty or incomplete values. Missing data occurs in various fields, including environmental and air pollution data sets due to reasons such as equipment malfunctions, manual data entry errors, or even inaccurate measurement. When not handled properly, missing data can introduce bias, impair data effectiveness, and lead to erroneous conclusions. Thus, we need effective methods to manage missing data before proceeding with any analysis. Here come the objectives of this present study. Our main objectives are twofold. First, we aim to examine 6 different single imputation techniques for managing missing data. Second, we seek to identify the most effective method in handling missing data for ozone concentration, especially when different levels of missingness are present. Let's move on to the methodology. The ozone concentration data was collected from the Malaysian Meteorological Department for the Petaling Jaya area in Selangor. We collected hourly ozone concentration data from January to May 2020. This provided a rich data set, but also one that included several gaps due to missing values. So here come the statistical methods that we perform, which is the imputational methods. Now let's briefly look at each of the 6 imputation methods that we use. First is the linear interpolations. This method estimates missing values by connecting two non-point within or with a straight line, and the formula is given by this. The second method is cubic interpolations, similar to linear interpolation but fits a cubic curve, making it more flexible for curvy linear data, and the formula is given by this. And the third one is mean before and after method, or MBA. It fills in missing values using the average of the nearest observed values before and after the missing point, and the formula given by this. And number 4 is the last observation carried forward, LOCF method, where it assumes the last observed value is the best predictor for the missing value. And number 5 is the mean substitution method, where it replaces missing value with the overall mean of the data set. And the last one is the median substitution method. This one is quite similar to mean substitution but uses the median value, which is more robust to outliers. Okay, now let's look at the results. This study obtained the simulated data by first fitting a Weibull distribution to the ozone dataset. The estimation process yield the shape parameters and the scale, or this one, alpha parameters, which characterize the distribution. We obtained that overall the beta parameters or the shape parameter is equal to 3.9 and the alpha parameter equal to 0.02. When data are missing at varying percentages, the estimated parameters deviate from the true values of the underlying distributions. And this is the result for the shape and scale parameters for number of sample size equal to 150. We can see that shape parameter beta exhibit greater sensitivity to the proportion of missing value, and the estimated beta deviate more substantially from the true value of 3.9, ranging between 4.42 and 4.46, and in most cases the estimated alpha or scale parameter remain close to 0.02. And this is the result for performance of methods for number of sample size equal to 50. We can see that we have 6 methods over here: MBA, linear, cubic, LOCF, mean and median. And this is the performance analysis. PA, prediction accuracy. MAE is the mean absolute error, and the RMSE is the root mean square error. Okay, from this we can say that the data demonstrated a consistent trend. As the percentage of missing values increases, prediction accuracy or PA decreases, and the mean absolute error or MAE and the RMSE values exhibit a positive relationship with the percentage of missing values. And number 3 is the mean before and after method. MBA yielded the most favorable result, the one in red color. For a sample size of 50, produced the lowest error than the others for all missing value percentages. And the cubic interpolation, the blue one, exhibited the least favorable performance across all missing value percentages. This is the result for sample size of 50, the small sample size. And this is the result of performance for sample size 150, which is medium sample size. Okay, the MBA method emerged as the most effective imputation method, consistently delivering superior results compared to other approaches, as similar found by previous study. Okay, the red one, and the LOCF, the blue one method, outperformed the cubic interpolation at lowest missing value rates 5% and 10%. And cubic interpolation, the green one, maintain its position as the method with the least favorable result, with the highest overall error. Okay, this is the result for the estimated parameters of original and imputed data. This is the original data with the missing value, and this is the imputed data, the one we applied the MBA method, the best method just now, which is the MBA. This data consists of 720 hourly ozone concentration value available for January, with 5% or 34 observation of missing values. As the result, the parameter estimates for the shape and scale along with the standard deviation are lower in the imputed ozone data than the original data containing missing value, which indicate good estimation. We can see that the red one over here is less than this one. Okay, for the conclusion, across all missing data scenarios, the study observed a progressive deterioration in prediction accuracy as the percentage of missing data escalated. And we obtained that the mean before and after method emerged as the most effective for ozone data, and linear interpolation and the last observation carried forward or LOCF method also demonstrated comparable performance, and the cubic interpolation method yielded the least favorable results. For the acknowledgement, this research was supported by University Malaysia Sabah through UMS grad scheme, and we would like to acknowledge the invaluable contribution of the Department of Environment and the Department of Meteorological Malaysia in providing the data used in this study. These are some of the selected references used in this slide. With that, I end my presentation, and I'm happy to take any question. Thank you.